Good morning and welcome to part 4 of building the DJH A8 kit, and today we are going to do page 3 of the instructions. This consists of fitting the wheels, pickups, cylinders, cylinder drain cocks, and a little bit of wiring and the inside motion way shaft. There's a number of etched parts, there's a number of white metal castings, and there's a certain amount of work to do connected with the wheels. Now, this page is quite instructive. There are various instructions at the top of the page, which you can see. How the motor fits if you've bought the Slater's motor, although I've got an ABC one, which is slightly different. There's the instruction on the wiring, there's how to fit the balance weights to the wheels. They're not all centered, and there are 3 different types, so they need to be fitted in pairs. There's a section here on reminding you that the wheels themselves, the Slater's wheels, need a certain amount of preparation, and also that it's important to fix the crank pins, the screws in the wheel bosses, and tells you how to do that. And then below it's got a reminder of where all the parts fit. So what we're going to do first, I've done a little bit of preparation prior to opening this. So what I've done is I have done the wheels, I've fitted the balance weights. All I can say about this is that the balance weights, they're nicely etched. All it is necessary to do is dress off the etching cusp in the middle of the outside surface, and it fits nicely. This is one of the leading drivers. It fits nicely in the arc of the wheel rim, the steel wheel rim, and it's thin enough to actually sit on. There's a slight ledge where the plastic meets the steel, and it does fit very nicely on the ledge. The leading drivers, the wheel weights are centered over the boss. The middle drivers is a larger etched part, and that is slightly off center. And the rear wheels is a smaller balance weight, and that's also slightly off center. All this is explained in the instructions, and it's very, very helpful that there is a drawing of these so that you can actually see where the ends of the balance weights line up with which spokes, which is extraordinarily useful. Normally on locomotives you just put the balance weight in the centre, especially if they're a 2-cylinder locomotive. The balance weights are there to offset the movement arc of the moment of the rotational moment of the coupling rods, so they're generally directly opposite those. But on a 3-cylinder locomotive they tend to be in a different position according to they have to balance out extra stuff from the inside motion. I'm not all that familiar with the layout of the inside motion of this particular locomotive. Although it was a 3-cylinder locomotive, there's good odds that it was set at 120 degrees, but people who are more knowledgeable about northeastern locomotives will probably know better. So we've got our chassis from the other day. If you remember, we've fitted all the white metal parts, and again it's just a question of fitting more white metal parts using a similar method. So tin the outside with 145 degree solder, and then with 70 degree solder, and then use indirect heat. The castings are quite large for this. Most of the castings are quite large for this, and what I'll do is I'll start fitting them and tell you what I've done at various stages, like I've done in the other parts. Okay, so we've moved on a little bit now, and what I've done is I've done quite a bit of preparation work for the castings that are required for this stage. So you have two cylinder castings which are quite large. There's a little bit of flash on them that will need cleaning off. I've not bothered dressing the front surfaces yet, and I'll do that after they're soldered on. You will need to drill two holes in the bottom of the casting. There are witness marks for these. I've drilled them 0.7mm or 0.75mm just for the moment, and what you need to do with these castings is you need to check the fit in the slot here, this slot. You need to check the fit of these to make sure that they rest against the chassis. This is important because the slide bars and everything, you'll have a skewed path for the slide bars and you'll end up with problems later. So I've been checking that these fit in the slots. I've removed the etching cusp on the inside with a needle file. I favour these, which are diamond needle files, not the normal crust cut ones. That's because they don't take off too much in one go, and they're easier to control, I find. Same thing applies for the slide bar brackets. These are white metal castings, very little flash to clean up on these. Just dress the back so that it's reasonably smooth using either a scalpel or needle file, whichever one you favour, or like I showed you the other day, I've stolen a number of my wife's nail files, which come in various grades, and some of them are washable, so they're quite useful for modelling, and they're not all that expensive either. So moving on from that, I've removed the slide bars and the cylinder rear and the crosshead. They come on one casting, and I've worked on these so that they're nice smooth, they don't catch, so that I've got nice motion and everything. These they took me quite a little bit of work. There's necessary to dress the slide bars to a certain extent. The hole, I would show it that way, the hole where the piston rod goes through, that needs drilling out to at least 2mm, not much more than that. So I drilled it out 2mm, and then I used a large tapered broach to make sure that the hole was a decent size. There is also a possibility that the casting, the piston may not be directly in line, so it will be necessary for you to hand do it just to get it correct. Also, there's a certain amount of filing necessary on the piston head where it attaches to the slide bars. So just generally work at that until you get a nice sliding fit, so that the motion runs nicely when it's all in place. There's another thing to tell you, that the crosshead, it's difficult to see, but there are two witness marks on the crosshead directly above the hole where the connecting rod attaches. There's two. The top one needs to be drilled out, so whichever way you orientate your slide bars and the cylinder end, you need to drill out the top hole I've drilled it out 0.6mm on both, and that's because on the same sprue that the crosshead and slide bars and cylinder front come, there is a tiny part which you may see here, this part here. It's got a number of L3, and it is a lubricator that fits on the top of the slide bars. Sorry, sits on top of the crosshead. And what I'll do when I'm getting ready to do this, before I fit the crosshead and the piston rod is actually in on the next page, but it is important that you get this fitted correctly now, which is why I've done it now. And the I don't know if you can see that the end of the piston, where the piston rod disappears in it, they are handed, so you'll need to make sure that those are correct as well. Now, the other thing that I must mention, when you first come to the slide bar casting, there is a possibility that when you put the piston rod in and the crosshead, that it will push the bars apart. Now, the easiest way to check this is to check it off against the casting where the slide bars rest. Now, I haven't soldered anything in yet, so I would recommend not soldering in this part before you've checked that the slide bars are the correct distance apart and they will actually fit between the jaws on this part. I think that is going to be quite important, because if you don't do it now, you won't be able to do it later. It'll be very difficult to do later. And the crosshead is designed to be removed, so you can pull it out all the way through the jaws where the slide bars sit, so that you can remove the connecting rod for painting. So it is quite a good design that way. What I'm going to do now, I'm going to leave the piston fronts off because they're white metal, and I think that it'll probably be better for me to glue them on. I've checked them, they are a reasonable fit, they just need a little bit of dressing. So I'm going to go away now. I'm going to fit, firstly I'm going to fit the cylinder castings to the chassis, then I'm going to fit the crosshead and the slide bars and the piston end in that, and then I'm going to fit this on top round the back. Okay, so I'll go away and do that now and then show you what I've done when I've done it. Okay, so I've fitted the cylinders and I've fitted the slide bars and I've fitted the slide bar supports, the white metal parts. I'll just rotate it around that way. So these bits here, that's probably better. They're the slide bar supports, which are also white metal pewter. Now, how I did this, I tinned the inside rim of the lost wax casting for the slide bars and the piston rod end. I soldered these pieces to after tinning the inside faces, I soldered them at the top and the bottom. If you get a good fit, it's not necessary to solder down the sides. There is some half-etched detailing there that you may obscure if you get it wrong, and it's more to clean up anyway, and it's not, if you get a good fit, it's not noticeable. So I did that both sides, soldered the cylinders in first, then having got the fit for the slide bar supports, I put the lost wax casting of the slide bars and the cylinder end into the white metal casting for the slide bar supports, pushed it all the way back this way, positioned this in its slot with this bit hanging loose, just positioned this in the slot and then slid the slide bar forward so that it engaged with its hole in the cylinder casting. That way it allows the cylinder, the slide bar casting, and the slide bar support casting, it gets its right level, so the two slide bars are vertical. Once that was done, then I soldered the white metal casting at this end, the slide bar supports. You have to make sure that you get them the right way up, so it's the curved bit at the top, so get that the right way up. Then once that was soldered in position, slid this forward, made sure it was a good fit with the casting, already tinned the inside edge with 145 degree solder, then just ran a fillet of white metal 70 degree solder around the outside, and that's fixed it in place. The other thing that I did, if you remember, I did mention that the crossheads and the piston rods are actually on the next page of instructions, but I thought it better to leave them fitted now, so I've fitted them now. And if I get something to point with, it's going to be quite hard to see. There is just underneath the tweezer point, there is, if you remember, I said that there are two holes that need to be drilled in either crosshead, and that is for a lubricator, which is the tiny part on the same sprue that the crosshead, slide bars and cylinder front comes on. Whatever you do, do not use a pair of wire cutters to remove this bit. The part is actually no more than 2mm by 1mm. If you use cutters to remove it, goodness knows where it will go. I use the Dremel with a cutting disc in, a thin cutting disc, to remove them. I soldered them in as they are, and what I'll do is when I come to do the cleaning up of the work, I'll clean those up as well. I've also done there's a dummy way shaft for the inside motion. That's the two parts that look like hammers. Now they sit in the cheeks, which you folded up in part in the construction of page 1. They sit proud. You can just see this sort of there's two bearings, dummy bearings. It's necessary to drill the holes out in those to probably 2.2mm to 2.1mm to get this casting, which is one piece, is to get it to fit. You can do that just by easing the cheeks out and then pinching them together. Solder it in place when it's centered. I'll go away and do that in a minute. The other things that I need to do, I've got to do some dummy inside piston rod, valve rods, which is 3 lengths of 0.7mm wire, and then there's a cross shaft that needs to go across the front of in front of the cylinders, and this is for the cylinder drain cocks. The hole isn't evident in the chassis, but there are 2 raised half-edge bolts with a dimple in between, and that needs drilling out 0.7 or 0.75 like I did. I drilled it out 0.75. So what I'm going to do, I'm going to go away and fit those bits and then show you what I've done again, and then this part is almost finished. All that's left once that's done is to fit the wheels, to fit the pickups, and then we should have a rolling chassis with a bit of luck. Okay, so I'll go away and do that and then show you what I've done. So we've gone away and done what we had to do, as I mentioned before. So the two hammers look like two hammers. They're the way shaft for the reversing gear. We've soldered that. We've centralised it between the two vertical mounts and soldered it with low melt solder. I fitted the 3 dummy piston rods, which you can see there's 2 on this side and 1 on the other side. So they're just 0.7mm wire. We fitted a 0.7mm wire across the front through the 2 holes, as I mentioned. It isn't immediately visible from the instructions, but these wires bend down. They must bend down, and I'll explain why in a minute. They must bend down from where they pass through the chassis. So I've soldered it in as a complete piece. As you can see, I've had to put a bit of a joggle in. Try and get something dark. Let's see what we've got. What have we got? Alright, that'll do. So I've had to put a bit of a joggle in the bit of wire. The reason for this is that they are the supports for the cylinder drain cocks. So the cylinder drain cocks are brass castings. They're given separate numbers, but they look identical to me. However, they may not be, saying that. And again, the etched part, the operating levers, they are given different parts, but they do look identical. So the 2 holes that if you remember, I drilled in the bottom of the cylinders, I drilled them 0.7mm. They need to be opened out to 1.3 or 1.4mm to accommodate the spigot of the mounting spigot for the cylinder drain cocks. Again, as I mentioned with the small part on the cast sprue for the crosshead, be careful removing them if you're going to use cutters, because they tend to shoot off in all directions and there are no spares. So what I've done with this is that I've drilled the 3 mounting holes for where they're attached to the castings and the wire. They're 0.75mm. I've also drilled out, there are sort of half-etched holes in the operating arm. I've drilled them out 0.5, and later on, when this is all finished and settled, I'll probably fit a couple of 0.5mm rivets to represent the hinges. So I won't do that now, but that will be done before we're ready the next time. So again, the other thing that I've done is, as well as fixing the 2 cylinder drain cock assemblies at the bottom, the actual castings aren't fitted yet. They're held in place by the etching, but I'll sort that out a bit later. I'll probably glue them in, as I will do with the cylinder fronts. As I mentioned, the other thing that I've done is I've taken the housings for the Slater's pickups. The chassis is etched to accept Slater's pickups. I know some of you have preferences about which ones you use, but I've used Slater's ones because that's what's specified in the kit, and the holes are exactly the right size once you've cleaned off the etching cusp to accept the black housings for Slater's pickups. So they're fitted. I'm just going to let them dry. Wherever I use glue, I use this 60-second super glue, Loctite super glue. It gives you a chance to reposition stuff if it's not quite right. All the gluing that I've done, including the balance weights and that on these, I've used that glue, and it's quite effective as long as you leave it to go off. So I'll leave the glue to set. I'll put the cylinder fronts on, glue the cylinder cocks in place underneath, just a dab of glue, and then when we come back I'll put the wheels on, and that will be this session will be finished once the wheels are on. Okay, so we've got to the stage now where we have fitted the pickups and the glue has gone off. I've also fitted the wheels. You have to be careful about fitting the wheels because not all the wheels use the standard Slater's 12BA steel screw. So what I've done with the wheels is I hand drilled them with a 5.5mm drill held in the hand to give it a countersink, and then I counterbored the rear with a 2.2mm drill, and then if you look at the crank pins, you will see that they're of different lengths. This is catered for in the kit. DJH supply 2 pairs of long screws for the front 2 wheels, the front 2 driven wheels, and you use the standard Slater's one for the rear one. You need to not discard, or you mustn't discard or put elsewhere the Slater's crank pins that you have saved, because they are used elsewhere on the kit. So it's very important that you keep everything safe in the out of the packages, the small plastic packages in the Slater's wheels. Keep everything safe because you're going to need those on other occasions. Right, I'm just going to ease the front driving wheel. For some reason it's gone very tight, so I'm just going to take the front drivers off. It may be that I've got a bit of Loctite in the wheel, in the axle. What I did for the screws is I screwed the screws in through the hole. They normally self-thread, and they certainly did with these wheels. Self-threaded, screwed all the screws all the way in as far as they go, provided you have counterbored the rear of the wheel sufficiently. The wheel will go so that the head is below the plastic, and that's what you want. Yeah, I've got a bit of Loctite in it. Okay, so you can see counterboard. Then I put a drop of Loctite 603 thread lock. You can use whatever you use. If you use super glue, use super glue. I tend to use thread lock because at least you can undo it if accidents happen, and accidents do happen. So I just remove this axle. I've got to be careful because you can't actually put the wheels on an axle and then feed them through, because you've already fitted the brake shoes. So you need to be quite careful with that. Yeah, so I've got a little bit of Loctite on the inside on the axle. What I'll do is I'll clean that off in a minute with a bit of wet and dry paper, and then I'll take it all apart. What I do is I keep the wheels separate from the axles and the axle screws. What I use is a small, I had it a moment ago, where did I put it? Boris, have you eaten it, Boris? No, you haven't eaten it. Well, anyway, when oh, there it is. Straight in front of me. Small Ziploc top bag, put a couple of drops of oil in that, and then drop your axles inside, and then there's no tendency for them to corrode or rust or whatever. Normally the wheels go in another bag, but without the oil. So that's it. I tried it before the wheel seized up. It does run quite well. It's level. There's no rock or anything in it. The middle drivers don't go round. I wouldn't expect them to, because the axles are floating, if you remember. It is quite front heavy, so if you just push it by hand, it will tilt down. So the next instalment of this will be fitting the rest of the motion and the rear wheel and the sandpipes. So I hope you've enjoyed this, and hopefully I'll be able to move on to page 4 sometime at the weekend or early next week. Thank you for watching.